Okay, so we wrapped up yesterday, and there was a active bug in our code, and it was just a simple bug. The bug was in the method insert tail. What the bug was, and let me just repair or put back sort of where the bug was we had this line of code right here, length plus plus, increasing the length of the list, only inside the else statement. And that is a problem. Because if you add a node to an empty list up here, it will not increase the length. So that's a problem. So we have two possible solutions. One, we can put length plus plus here as well. That would fix it. And there'd be nothing wrong with that. But now you'll notice we have this line of code in both if and else. And whenever you have that happen, when you have one line of code that's both in the if and in the else, there's no need to do that. If the if-else statement is not controlling that line of code, then I would move it outside the if-else statement. So that's what you need to do to fix the bug from yesterday, is just take that line, length plus plus, and place it after the end of the else statement. Because it will increase the length no matter what when we call insert tail. Now you think, well, why didn't we do that in insert head? Why didn't we put this outside the else statement? Well, because if it's empty with insert head, we call insert tail, which would then do it there. So if we did it inside of insert head, we would be creating another bug. We'd be adding one more than we need to. So again, got to be careful about the way you structure your logic. But now when I run this, you can see that the output I'm getting is the correct output. It is outputting the list in the correct order. And I'm just going to add one more line to this. Like here you can see in main, the way I had written main was to create the list, insert a 10. If I try to spit out the 10 after I put in, like I'll do this, that's what the list looks like there. Then I put in the 5, that's what the list looks like there. You can see the actual order. So here's the list when I have a 10 in it. Here's the list when I have a 5 in it. Here's the list when I have a 20 in it. And actually, I'll even add one more. Here's the list before I put anything in it. So now when I run it, you can see the way it did it. It said it was an empty list. Then it was a list with just a 10 in it. Then it was a list with a 5 and a 10 in it. And then a 5, a 10, and a 20 in it. Okay? And again, I could add more to this if I wanted to. I could say list.insert head. And I'll just put a 0 in there. And then output the list. And I'll say list.insert head and put 100 in there. And then output the list. And again, this is just for testing purposes. But here you can see that it's doing what we want, right? So the 0 was inserted to the head of the list, and then the 100 was inserted to the head of the list. It doesn't sort these. It's just doing what we ask it to do in the order that we're asking it to do it. Okay. So now, the next method we're going to write after insert tail, and again, you can kind of put it anywhere, is we're going to write a method to set a value. Okay? So we talked about this in our to-do list. We said, you know what, let's set a value. So this is something you can do with arrays. You can say to an array, you can do this. You can go, it's like array spot 9 equals 79. Like you can put code in like that to set it. But we need some parameters here. In order to set it, we need to know what spot we're setting. So let's give it the parameter int index. So that'll tell us what spot it's setting. But we need one more thing. We need t data. We need the data that we're going to set it to. So we're going to give it new data that's going to be set. Remember from yesterday, T is a generic data type that will be defined when we instantiate this class. Okay. So the idea here is that we'll have a list that will already exist, or it won't. We'll error check that. So the idea is we have this list. Let's say it's this list. Okay. Null, null. Let's say this contains 5, 10, 15. Okay? You know, we also have something called head, and something called tail, and something called length, which right now is holding a 3. That's what our list, let's imagine, looks like. Let's say we pass it the value set index 1 to be the number 20. We pass it those two values. What you think should happen is, like an array, in theory, it would index this 0, 1, 2. It would find spot 1, it would find this spot, and it would change the 10 into a 20. That's what we want this method to do. If we give it something like index 10, which is beyond the list, we should not crash. We should error check that. We should also make sure they can't give us a spot over here, something like a -1. That will not be allowed. That's something that arrays can't do. They can't check beyond the bounds, but we can. We're going to build that in. So we're going to build that into what we need to do here to make this work out for us. Okay. So in order to set a value, we need to find the node that we're going to be setting. So we're going to make a node called node equal to, and what we're going to write is a little method called getNode. And we're going to pass it the index. This will be a little utility method we'll build within the class that will give us a reference to the node we're looking for. Now, if the node shoots out of bounds, like if it goes beyond the edge, we'll return a null value right here, which means it shot past the end. So if that node is not equal to null, then we're going to do something. Because if it's null, then we don't want to do anything, because that's invalid. We could pop up some fancy error box or something like that, but we're not going to even bother with that. But then if it's not null, all we have to do is we say node.data equals data, and we're done. So that's it. That's all the set method has to do, is it gets the node, and as long as it's not a null, it'll put what the data is inside that node to be the same as the past data as a parameter. Okay. So that's it. That's all set does. But in order to make set work, we have to write this method getNode. Okay? Okay, so let's make this method, and it will be a private method. You can use the light bulb to write it if you want. Private node getNode into index. Okay, so this is a method that returns type node. It doesn't make a new node. It doesn't build a brand new node. Instead, what it does is it returns a reference to the node. Again, this is why I was so strongly mentioning that word reference on our first day. Okay, so here's what getNode's going to do. It's going to assume we have a list, or not. It'll account for that. Okay, so we got a list here, null, null. I'm going to pass it, for example, the number 1, and it's going to basically assume this is 0, assume this is 1, and return a reference to that node. So it's going to have to go through the list, it's going to travel through the list, counting as it goes through. Now this is something we did very quickly yesterday, is a way to travel through the list. So that's why I'm going to spend a little more time doing that as well. But in addition, we're also going to do this. If we give it the number 10, we're just going to crap out on them. We're going to return null. So that's going to be a little bit easier to deal with, is numbers that are outside the range of the list. Because we're going to take care of that with a little method. We're going to say if in range index, okay, then we will do something. Okay? If it's not in range, if we go beyond the if statement, we'll return null. Okay? So what I'm saying is we will build logic inside this if statement that will check to find the node. But if that's not true, if it's not in range, we'll just send back the null. So we're going to have to now write this little thing. This will be simple, a little in-range method. Okay? So let's write that underneath, a little private, and again, you can use the light bulb, Boolean method called in-range into index. Okay, so how's this in-range going to look? Well, it's pretty simple. Okay? Here's something we know. If the list is empty, which, by the way, we already have a method for. If is empty, return false. You can't possibly find even spot 0 in a list that's empty. There are no valid spots. So if it's empty, we're done. Now, it's possible that the list isn't empty. But if they give us an index that's less than 0, there's no spot less than 0. Let's return false. That's not in range. There's no spot that's like -5. There is no negative spot. And then what would be the final one? If the index would be what? If it's greater than or equal to the length. Right? Our length keeps track of how many nodes. And if that's the case, we'll return false. Okay? So these are the 3 scenarios where this would not be in range. Where the list is empty, where the index is less than 0, or the index is greater than the length. And then for the else, that's where we go, well, okay, fine. Let's return true. That's in range. That number you've given me is in range. Okay? So these are the 3 scenarios where it would fail, where it's not in range. And then the else just takes care of any other number that is in range. So that's our little in-range method that just determines whether or not the number that we're trying to get is inside it's built-in error checking. Okay, back up to get node. Okay, so now we're back up here in get node. So now here's what we know. We know that the number that they gave us is somewhere within the list. We don't have to worry about any kind of crashing because this number, whatever it is in the list. So, for example, if we have a list of 3 nodes, could be 300 nodes, doesn't matter. Actually, let's just say this goes on for a long time. Okay? And this ends, and this is the head here. Then way down here at the end is the tail. Okay? So that's the head. Way down there at the end is the tail. Could be like 3 million nodes running in our program. Let's say we ask for spot 2. That's our index. So it'll come down here and it'll check to see if it's in range. So let's say the length right now is at 100 nodes. Let's say there's 100 nodes in this list. First of all, it'll check to see if it's empty. And all this empty does is check to see if that number is 0. Well, it's not. No. Is the index less than 0? No. Is the index greater than the length? No. So it's in range. 2 is within the range of this list. Sounds good. So what we need to do now is we need to travel through this list and get to spot 2. But unlike an array where we can just ask for a number and get it, we can't do that with a linked list. The only way to get into a linked list, to enter the list, is either through our head node or through our tail node. Those are the only access points. So what we're going to do is we're going to make a little temporary node. We'll call it current. We will start it off at the head. And what we will do is we'll keep a count going. And we'll say, okay, we'll start the count at 0. And we'll say, does this thing match this thing? Does it match that number? No. So if it doesn't match the number, we will move current to the next node. And we'll keep doing that as many times as we need to, shifting it along and each time adding 1 to this. When this number finally does match that number, we're done. Whatever node we're currently pointing at, that's the one we'll return at the end. So that's what we're going to do logically to do this. And so let's get started. Okay, so we'll start by making a node called current. But what we won't do is we won't say current equals a new node. We're not building a new node. We are referencing a node And the one we're referencing is the same one as the head node. So what this does is it creates a pointer to the head node, just like the head node itself. So now we have two things pointing at the head node. We have head and we have current. And now we start a for loop. I equals 0. Well, I is less than index I plus plus. So that'll do the counting for us. I will count. And it'll count up to index. How do I shift current to move to the next node? Well, I do this. I just say current equals current dot next. Let me stop for a second and explain how that works, okay, as you guys key that in. Let's draw a quick linked list here. Okay. We also have backwards things going here. Okay. This is a null. Over here, that's a null. Okay. So what we have here is we have something called head, and we're done. Sorry, guys, that's it for today. I wasn't watching the time. We will finish on Monday.